In this video of the PSA plant maintenance series, we will be joining biomedical engineers at a PSA plant. We will learn how to complete the daily checklist.
As you learned in the last module, it's critical to complete the daily checklist each day. Today, BHI biomedical engineer Jonas is on site at King Faisal Hospital in Kigali, Rwanda to walk us through many of these daily checklist tasks. Let's follow him step by step. Before entering the PSA plant or container, always make sure you have the proper personal protective equipment, including gloves and hearing protection. We'll start with the visual inspections. First, Jonas asks, have all combustible materials been removed from in and around the PSA plant? He spots some tissues, boxes, and other combustible materials, so he removes them right away. Has the floor and all surfaces been mopped and dusted? Jonas sweeps the work area to keep it clean and safe. Is the PSA plant free of any physical damage? Jonas walks through the PSA plant, inspecting the exterior of each piece of equipment to check for dents or other visible damage. Are cylinders stored safely with caps and chains? At the cylinder storage area, Jonas replaces a missing cap and ensures that the chains for the cylinders are secure. Are all ventilation systems working, including fans? With no fans to check, Jonas ensures that the passive ventilation windows are open and unblocked. Are air intake filter mats, intake covers, and ventilation filters in place? Here we show Jonas's counterpart removing the air intake filter to confirm it is present and in good condition. Are the air compressor and equipment housing covers in place? To ensure the airflow in the air compressor is as intended, the operator closes and secures the covers on the equipment. Is the air compressor motor belt free of any visible damage? Jonas inspects the belt carefully. Note that not all air compressors have motor belts. Is the air compressor oil level at the manufacturer's specified level? Jonas checks the oil sight glass to confirm the correct oil level. Is the bottom of the air compressor free from any signs of oil leakage? Jonas inspects the surface at the bottom of the compressor for leaks. Is the air compressor condensate draining correctly? Jonas confirms by pressing the test button. The same check is performed for the air dryer, inline filters, and air tank. Is the air tank condensate draining correctly? Jonas confirms. Some drains may have manual valves, like the air tank Jonas is checking. Operators must open these drains every day to drain the tank and confirm valve functionality. Operators should note if the condensate accumulation is particularly high. This could indicate a problem. Is the condensate draining correctly from the inline filters? Jonas confirms by pressing the test button. Is the booster compressor operating without unusual noises or leaks? While the booster compressor is running, Jonas listens closely and checks around the base for water or oil. If the backup manifold has not been used in the past day, does the pressure gauge indicate it's maintaining pressure? Jonas confirms that 122 bar shown on the automatic manifold display is reading the same as the previous day, indicating no loss in pressure. Are the manifold pigtails in good working condition? Jonas examines each manifold pigtail for wear or damage. Are the fire detection and suppression systems in good working condition? Jonas looks up to the fire suppression system on the ceiling to confirm there is no damage or missing components. Jonas also checks the fire extinguisher and confirms it is within its expiration date. Jonas continues the daily checklist, moving on to the data collection portion. He must record the temperature in the PSA plant room or container. Jonas notes the reading from the thermometer is around 26.5 degrees Celsius. Jonas checks the air compressor temperature. This model of air compressor shows the temperature with a digital gauge. The green zone indicates the temperature is within the manufacturer's acceptable limits. Next, Jonas checks the air compressor running hours. The display shows 22,047 running hours, so Jonas will record that value on the daily checklist. Record the PDP temperature, or pressure dew point temperature. Jonas reads the display on the air dryer and records the value of 5 degrees Celsius. Record the oxygen purity percentage using a handheld oxygen analyzer. While Jonas has the oxygen analyzer turned on and calibrating in open air, he prepares the flow meter settings at the wall outlet for his measurement. He first ensures that the oxygen flow meter is set to a flow rate that is compatible with the oxygen analyzer he is using. Then, he connects the oxygen analyzer to the wall outlet. He waits for the displayed oxygen purity on the analyzer to stabilize. The purity stabilizes at approximately 89% oxygen purity. Record the oxygen purity percentage from the PLC display. Jonas now checks the oxygen purity as the PSA plant is recording it. The display is showing a value around 94%. He also records the oxygen generator running hours, shown on the same display as the oxygen purity. Note that the oxygen purity Jonas measured with the handheld oxygen analyzer is different from the oxygen generator display. When this happens, further investigation is needed. These two measurements should be the same or very similar. Record the booster compressor running hours. Jonas checks the booster compressor to see that the total number of running hours is 8,287. He will record this value on the checklist. Record the booster compressor pressure gauge readings for each stage. Jonas checks and records each pressure one by one, clearly specifying which pressure recording is for which stage. This booster compressor does not have a temperature display, so Jonas does not record it. Enter the number of cylinders filled for your standard cylinder size. Jonas counts the cylinders filled today. Jonas will also record the number of hours the booster compressor ran today to fill the number of cylinders shown. Compare the running hours with the preventative maintenance schedule. Is service needed? Jonas cross-checks the daily checklist with the preventative maintenance log to plan ahead. If any of the running hours he recorded today are getting close to the next service interval, he will need to check his spare parts inventory and start planning for a day of maintenance. Thank you for joining Jonas as he completed the daily checks at King Faisal Hospital. We hope that you will emulate Jonas's attention to detail as you complete your own daily checklists. By giving this critical task the attention it deserves, you will keep your PSA plant running safely and efficiently so that it can deliver oxygen to those who need it most.
We hope that you have enjoyed this video on how to complete the daily checklist. Continue on to learn about reviewing the daily checklist.